Hi, I'm Grant Evanishin. I'm an instructor at the College of New Caledonia, and this video is about front differentials, or front drive axles is what they can be called several things, but I'm going to have a cutaway here, and I'm going to do show you the parts and the operation of it. So I'm going to try and do this without a break, so it's easier for me to make the video, but anyhow, we'll see how this goes. So this is my cutaway of an Eaton Diff, okay? So I'm going to show you all the parts of it, okay, and the purpose of it. So let's start with the purpose of it. We need to drive our axles. Our axles spline into here and go out to the wheel ends. That's what drives the vehicle, okay? This side here, this end here, is basically where your yoke would mount, your U-joint, your drive line. So you take your power coming from the engine, goes through the transmission, receives a gear ratio change for whatever gear it happens to be in, and we come back to here and we transfer our power in through the input. If this was a rear diff, this is a front diff, so that means it's got a power divider in here, or a interaxle differential in here, okay? And that means we're gonna drive two things with this. We're gonna drive the back axle at the back out this shaft there. This shaft here is gonna go out through the back of the pumpkin or banjo or drive gear housing, right? There's going to be another yoke on here that's going to drive the back axle, okay? This is the front diff, we're going to call it. Sometimes you might call that axle number 2. Another name for this item is called a third member. And so we drive into here with our yoke, and that everybody says, oh, what does that drive? What does that drive? You can see it's turning the output shaft because there's too much resistance down at the bottom, okay? On a rear diff, you basically have a pinion, which looks like this, and you have a crown that looks like the crown around here, right? This is the crown, okay? So the pinion drives the crown and gives us a huge gear reduction, somewhere in the area of 3, 4, 5, 6, 7 to 1, okay? So that gear reduction gives us a slowdown in speed because our speed coming in to the differential is huge. We need to slow it down and we need to gain some torque so we can turn the wheels and move our load, okay? So our input shaft comes in here and it goes in and we say, oh, well, it drives, what does it drive? It drives this. But it doesn't really drive that because what's in here is a differential, okay? There is actually 2 differentials in this, and I'll show you the other one in a moment, but this is the interaxle differential. So this actually allows for a difference in speed between the front and rear axle. If one is on ice, if you're going around corners, if you're on rough ground, anything like that, you need to have a difference in speed so that they won't, your tires won't scuff. Okay, and the axle or the differential that sits down in here, in the center of the crown gear between the case halves, that one gives a difference in speed between the 2 axles. Okay, so we come in here, and the thing that this input shaft is driving is actually this, and some people call that a cross shaft. I call it a spider because it's got 4 of these things coming around, right? And you've got side gears, one that goes out to drive the back axle. This side gear actually is connected to this gear, which comes down and drives the pinion to drive this axle, okay? So you've got a dual highway commercial vehicle that you're using this with, okay? So we come in here and we drive that. Depending on what torque we're requiring or what speed we're requiring, any difference in load will cause a different one to turn. This thing is turning that side gear. If I stop that side gear, because it's attached to that, I can actually, so maybe I can't. Maybe I'm just not strong enough to turn that, okay? So what happens is, it will actually turn the crown down below, okay? So, yeah, okay. So, if I were to lock that and turn that, I'm going to lock the output, so say it was stuck, and you want a differential between there, this will turn, okay? Now, it will actually, I'm doing it backwards, but picture this. This input is driving that gear, it's actually driving that cross, that spider in there, okay? It's driving that, and the difference in torque required, I'm going to stop this one, and it will drive the bottom one. It'll drive this axle, the front axle, right? Okay, and turn the crown, and it'll go through this side gear, okay? So, this is not connected to this. These two are not connected, but they, the drive for this coming in is actually driving that cross, okay? And these are your thrust washers that sit on your pinion gears. Side gear, this side gear drives the pinion, this side gear drives the output to the second diff, okay? So, when we want to get better traction, because if we've got the back axle on ice, let's pretend that we got the back axle on ice. There's not going to be any resistance. So our input speed is going to go like this. The back wheels are going to just slide, skid, do whatever, right? And this side gear will not turn this crown because all the speed is going out through here, right? And there's zero torque out there, okay? So if we wanted to lock it, if you get looking closely, you can see this thing that looks like a castle, like it's actually a jaw clutch, right? And it's really operated with air. I don't have air here, but we have this that will lock that together. You can see that happening. And that's locking the interaxle differential. So now we have locked the input shaft to the to this side gear, to this gear, okay? So we're locking this shaft to this gear. That means this cannot turn. So you won't get that rotation of these, okay? So now when I turn it, it turns everything. It will turn the output and the crown gear, and basically turn it at the same speed, okay? So now you've basically locked your front axle to your rear axle by locking this interaxle differential, this power divider. Sometimes the truckers will actually engage it while they're spinning because they get a spin out and they say, oh, I need it in, and they flip the button on the dash and it goes, tears all these off, okay? Okay, now I'm going to take you to a close-up of the stuff that's happening here. I just talked about the power divider lock there, the interaxle differential. So basically, this is the interaxle differential. Anytime you see a cross or cross shaft with side gears and pinion gears, that is your differential. Like I said, I've given you a close-up here now, but I've locked the whole system together, and now I'm turning that crown down there, and I'm turning the output shaft going to the back axle, okay? So that differential has to be the interaxle differential because it's between the front axle and the rear axle, okay? So if I take you around here, we're gonna see, actually we should look at the pinion first. You see that front of that pinion has a bearing? That means that it is it's got 3 bearings on this pinion, okay? So it's slightly below the center of the crown, making it a hypoid gear. It's got two tapered roller bearings there, and then one roller bearing or pocket bearing that's up there to handle to support that thing, because it's got huge amounts of torque going through it. Okay. You also notice that the teeth are curved, right? Just like the teeth on the crown are curved, right? Whoa, that went too fast. There we go. The teeth on the crown are curved. Now, when people talk about backlash on diffs, they're talking about, I don't know if you can hear it. It's hard to see. I'm moving that crown back and forth just a little bit. That is the backlash between the crown and the pinion. When people talk about the pattern, as we develop a pattern, this is the convex side of this tooth. Okay, you can see how it's curved. This is the convex side. That is the driving side. The concave side is the coast side, they call it, right? And if I can show you clearly down in that hole down in there, you can see the pocket bearing and the pinion. The pinion pocket bearing is right down there. Okay, so when we are setting up our pattern, we're going to put our bluing on here and turn it and see where it contacts our pinion, so that we can see if we've given it the proper settings for this. Okay, another part that we call this is actually the differential itself. When they say, oh, I took out my diff, they're talking about the whole housing, basically everything, right? But that differential right there is the one that splits the two axles. So just like the interaxle differential, this one is meshed. Each of those side gears is meshed to one of the axles going out. If you break one of the axles, the thing is just going to spin. The other side will not turn, because it's going to go to the path of least resistance. Okay? So what they put in is they put in a locker differential in the case halves. So these pieces here are the case halves, and we've got them cut away here, of course, right? On the crown assembly, you've got a flange side, which means that it bolts the crown to the flange, okay? And then the non-flange side, okay? So then you've got side bearings and gears that are set with those notched, well, they're a notched nut is what they are. With external teeth or external threads. So, okay, so pattern up in here, up along here, right? This is where we get our pattern on the drive side of the tooth. This is our output right here to the back axle. And if we come around here, you'll see that this is the actual air shifter that shifts the power divider, or the interaxle differential lock. Okay, so it locks the interaxle differential. So I'm thinking I've given you enough information to get into trouble, so we're gonna stop it here. But this is a front diff. A rear diff basically just has a pinion and a crown. It doesn't have this top end. So a front diff will always, as far as I know, have a pump. So it's lubricated up top by the pressure from the pump. On a regular diff, it can be splash lubricated because you're just doing the crown and pinion. You're just lubricating the crown and pinion. As soon as you put the interaxle differential up top there, you are going to, and it doesn't matter if it's a Eaton or a Rockwell, it will still need to put, it'll need to force oil up in there to keep that system lubricated so that it won't blow apart. So I hope this has been helpful to you, and I will be posting this and letting you guys see it. So thanks a lot.